Hi, today we're looking at Module 4, Lesson 7, Replacing Letters with Numbers. Hopefully you'll find this a review from some topics that you've covered in elementary school, okay? And this is going to help us build onto future lessons. But even though I'm sitting here saying it should be an easy review, if you don't find it an easy review, please ask lots of questions. I can explain it in a new way, or make sure you come to extra help and we can continue to review it. All right, let's take a look at example 1 in your notes. We have a square, and what is the length of one side of this square? Exactly, we don't know if it's centimeters or meters, so we say it's 3 units. Since it says it's a square, it tells us it's a square, we know that all the sides are 3 units, okay? So what's the formula for the area of a square? It is length times width, but that's usually what we would use for a rectangle. What could we use instead of saying length and width? Because that would imply the length and width are different lengths. Because there's different letters. L is one letter, W is a different letter. And usually different letters represent different numbers. But here everything is the same. What else could I say?
3 times.
Well, I want a formula, and that won't work for every example. That would work for this one.
You can do 3 squared.
But again, not everyone that would work for. Okay, that's the same thing that he had said. Right, we could say that the area isn't area equal to side times the side, because here, this side equals 3, and this side equals 3. So every time I look at S is going to be 3 in this case. So S times S can be written as side squared. So for a square, we want to say sides squared because every side is the same. S is always the same number for this problem. So what is the square's area as a multiplication expression? We're looking for an expression. Well, it would be 3 units times 3 units. That's the expression. So the area would be 9 units squared or 9 square units. Question, don't write this down, I just have a question. Instead of writing it those ways, that doesn't sound right. Could I write it like this, 9 squared units? No, because that would be 81 units. Now, first of all, units would mean it's just a distance, a straight line. And I don't have 80, that's not a length of 81 there, so that's not okay. It's the unit that's being squared, not the number. So please be careful when you're labeling your answers. So let's take a look at the second square that they gave us. We counted the units the first time. But this one, the length is 23. So that side is 23, that side is 23. Every side is 23. I don't know about you, but I'm not about to draw 23 boxes by 23 boxes. There's got to be an easier way. I could just go right ahead and write my expression. So what expression would I use? If area equals side squared, area would equal what? What's my expression? What expression should I use? 23 centimeters times 23 centimeters. So if I multiply 23 centimeters by 23 centimeters, 529 centimeters squared. Okay? Just trust me on the math. I just saved you some multiplication. So now let's take a moment and look at the 2 examples that we just did. For the first one, we said area equals side squared. Now for this one, S equals 3 because each side was 3 units. So here, S equaled 3. So area equaled 3 squared So area equals 9 units squared. But now here, it's the same formula. It's still area equals side squared. The area is the same. But over here, S was 3. What's S now? Now what does S equal? Now S is 23. So the area is 23 squared. So in this example, every time we see the letter S, I know it equals 23. When I did S times S, if that S is 23, that S has to be 23. It can't equal anything else. A letter represents one number in an expression. Well, here I have a different expression. When I did S times S, S was 3, S was 3. So in this first example, S was always 3, can never be anything else. So within one expression, it cannot change. In a different expression, it can mean something different.
So then you would use another letter to represent another number?
Absolutely. Very good. If I needed to represent a different number, I would use a different letter in that equation. Very smart question. I like it. Okay? Someone's thinking over there. All right, so right now, let's complete this table for the two squares that we just worked on. I'll do the first one together, and then you can try the second one on your own. So we see here that the length of one side was 4 units. Oh, there are two new examples. I apologize. So 4 units. So as an expression would be 4 units times 4 units. So the square would be, the square's area would be 16 units squared. Now you try the next row on your own. So let's take a look at what the answer would be. The length of one side is 25 units. So the expression would be 25 units. Oh, I'm sorry. You know what it is. It's inches. (25 by 25 inches). So the answer for the area is 625 inches squared. Any questions on that? All right, let's take a look at the next one. Now we have a rectangle. What did we say was the area for a rectangle? What's the area for a rectangle? Right, so now area equals length times width. And like we said, since we have two letters, each letter is going to represent a different number. Okay, L cannot have the same value as W. But here I see a B. How can I figure out the value of B? What does that represent?
Well,
if this is B and this is a rectangle, I know both sides of a rectangle are congruent. So what would B equal? This is the same as that. What would B equal? 8. So B equals 8 centimeters because opposite sides are congruent. They're equal. So if that's 8, that's 8. Now let's take a look at the second rectangle. This is 4 centimeters. And the information is telling me that each segment is equal. So if each is 4, if that's 4, that's 4, that's 4, what would X equal? I see here that X equals 2 of those units. So what would X equal?
X would equal 8 centimeters.
Good. X equals 8 centimeters. So what is the total length of this second rectangle? What's it? If each one is worth 4, look at that. If that's 4, that's 4, that's 4, what would the total length be? Right. The total length would be 16 centimeters. So now if the two large rectangles have equal length and equal widths, find the area of each rectangle. So I know that if these were equal, if that's 8, that's 8, that's 16. So I'm just going to redraw it. So 8 and 16. So my area is length times width. I was able to figure out that my length was 16. So if my length is 16, I can replace the letter L with the 16. My width I figured out was 8, so I replaced the width with an 8. So if I multiply those two numbers together, the area equals 128 centimeters squared. Okay, are there any questions on where those numbers came from? All right, so now we have a table with two new rectangles. So fill in the table with those two new rectangles. Okay, so let's go over the answers. The first one, the length of the rectangle was 7 units. The width was 4 units. So 7 units times 4 units. So the area was 28 units squared. Make sure you're properly labeling your answers, just like you learned to do so in your science unit. So 46 meters, 32 meters, 46 meters times 32 meters, 1,472 meters squared is the area for the second rectangle. Any questions on where those numbers came from? Okay. Enough about area. Let's take it to the next step. What do you think we're going to do next? Volume, right. So the formula for volume equals length times width times height. Now, like we said earlier, each letter represents a different number. So that's why we don't like using that X anymore for the multiplication symbol, because it can get confused as a variable representing a different number. But still, what does the L represent in the first diagram here? What does that L represent? In this first picture, what does L stand for? Length. What does the W represent? And what does the H represent? Height. So since we know the formula to find the volume is length times width times height, what number can we substitute for the L in the formula? I am going to tell you that these two are identical. A lot of times the directions will tell you not drawn to scale, which means don't trust the drawing to be like, oh, well that looks like it's like double the other one, so I'm just going to double the number. Don't start playing those games with your eyes and assuming that they're drawn to scale, okay, unless it tells you that they are. But here, they tell you that they're not drawn to scale. So just because this is 32, don't assume that equals 32. Oh, well, this is a little bit shorter than this, so this must be a little bit less than 32. Don't do that. Don't do that, because it's telling you it's not drawn to scale. But now I am telling you that these two are equal. So instead of saying L, what can I say? 6. I can replace the L for 6. What other number can I substitute for the L? What other number can I substitute for the L? How come nobody's raising their hands? No, because no. If L equals 6, you all just told me that L is 6. What did we say? Like in the first one, S was always going to be 3. In the second one, S was always going to be 23. So this is kind of a trick question. No other number. No other number can replace the L. Only one number can replace one letter. And this is our focus of our lesson today. Okay? So what can we substitute for the W? 2. And for the height, we can substitute the 8. All right. So now let's take a look at the next example. So volume equals length times width times height, and I know what each letter is. The length is 6 times 2 times 8. I can replace each letter with a number. So 6 times 2 is 12. Bring down the 8. I'm following my order of operation rules. 12 times 8 is 96. And I have to be sure to label it correctly. And how do we correctly label volume? Cubed. That's right. It's either cubic centimeters or centimeters cubed. Okay? You should be solving this at the bottom of your note page. So now you can take a look at the chart on the next page and fill in that table. All right, so the length of the first one is 12 units. The width is 5 units, 15 units. So 12 times 5, my smartboard is all wobbly in this one section, I don't know why. Then when you multiply those three numbers together, 900 units cubed, or cubic units. So for the second diagram, we have 23 centimeters squared, 4 centimeters, 7 centimeters. So 23 times 4 times 7, 644 centimeters cubed. So in closing, we realized an expression is a numerical expression or is the result of replacing some or all of the numbers in a numerical expression with variables. And we know that one letter can only represent one number within that same equation.